to learn about the Internet of Things. I just came from a DARPA conference, and my students already know about that, which was concerned about the future of technology. And one of the talk of that conference was the Internet of Things. So it's on the mind of many, many, many people. And so thank you for coming. Let me introduce our speaker. His name is Jim Goldman. He was a professor at Purdue for about 20 years, where among others he developed, let me get this right, the Purdue Malware Lab in the Department of Computer and Information Technology. After a while, the federal government got interested in his skills and asked, hey, why don't you work for us for a while? And so he worked for the FBI Cybercrime Task Force for a while. He then moved on to ExactTarget, did some work there, and soon after it got acquired by Salesforce. One of his former students, the founder of Cloud1, asked, Jim, why don't you work for me? And he said, sure, that sounds like a good idea. So he did. So his current position is Chief Trust and Security Officer, as well as General Manager for the IoT platform at Cloud1. And guess what their email address is? oncloud1.com. Out of Indianapolis. And so he will be our speaker today. So why don't we give a nice, warm Rose-Hulman welcome to Jim.
Thank you, everybody. It's a real privilege to be here. It's more of a privilege to be at the #1 engineering school. I haven't been at a lesser engineering school for 20 years. You know, there's a lesson here for all you students in the audience in that, you know, never say never, because you may end up being the boss of one of your professors one day. Not only is my current CEO a former student of mine, but when I went to work for ExactTarget, I also worked for a former student there as well. So pretty exciting. You know, it wasn't as awkward as it might sound. I actually kind of felt like a proud papa going to work for his son's company kind of thing. So in some small way, I felt like I must have had something to do with their success. And actually, in terms of managerial style, I could see a little bit of my own rubbing off on them. So that was kind of cool. I have some prepared slides that I think you'll find interesting. I will try very hard to keep those to about 25 or 30 minutes and leave a lot of time for questions and answers, because I'd rather have it be as interactive as possible and answer some questions. I don't know what all of your impressions or assumptions are about the Internet of Things right now, but I would venture to guess that when you leave tonight, you'll have a different impression than when you came in, all right? And hopefully I will have demystified it for you, so you don't think it's as scary as you may think now. So I'd like to start with a story about a company in Indiana that you may have heard of, in Columbus, Indiana, named Cummins Engine. They are the biggest independent manufacturer of diesel engines on earth. As you can see, about $20 billion in revenue. And one of the things they did in their diesel engine is they put an embedded controller in there to control the calibrations of the diesel engine. That in and of itself is not that unusual. If you know anything about diesel engines, you know that they're inherently dirty, you know, with emissions and so forth and so on. One of the interesting things that they did was they put an equivalent of a cell phone in there. And what that cell phone does is it gathers over 300 operating parameters from those diesel engines that are out there, and then can broadcast those operating parameters over a cell phone network and gather that data in. The problem was that Cummins Engine, it's kind of like any other large company, the right hand doesn't always talk to the left, and so the engineers that designed and put this embedded controller with the cell phone in the engine weren't part of the IT department or the networking department, so they had no concept, no way to understand how to get the data out of those engines and collect it and do anything useful with it. So for years, the embedded controllers were there, controlling the calibration of the engines, but the data wasn't really being used. It didn't go anywhere. Well, that's where Cloud One came in. And so we started with a very small contract with Cummins, just actually host them their application development environment that actually developed the firmware that went into the embedded controller. And then bit by bit, we took over more and more of this system that now is an independent business unit of Cummins Engine called Connected Diagnostics. So in terms of what we call the IoT maturity curve or the IoT maturity model, Cummins Engine is as far as you can go in our opinion, because they have actually developed and are now in business in a new revenue generating opportunity that didn't exist. So now this is the cool thing, and this is almost the differentiating factor for any traditional industry, because Cummins Engine is not making money on their engines at this point, they're making money on their data. All right, so wrap your head around that. All right, you know, the engine business is good and so forth, but now this is a new business, new revenue opportunity just centered around data. And it gets more exciting than that. So not only are they selling this data to, for instance, the big fleet operators that buy lots and lots of engines, the other thing that they're doing is they're able to bring all this data in, analyze it in this big data environment, and then remember how I talked to you about the calibrations? They're using the analytics, they're able to decide, well, how can we optimize this calibration, for instance, for changes in temperature, changes in altitude, that kind of thing. And then what they're able to do is the next time that engine comes in for service, that service technician takes their iPad immediately onto the internet, the latest calibrations come down, that embedded controller in the engine is then updated with those latest calibrations. Right now it only happens in the service bay. What they're picturing in the kind of the next generation is on the fly, as this diesel engine is traveling down the road in a truck, it'll pick up a nearby cell tower, the latest calibration will come down. Next time that driver turns that engine off and turns it back on, that newest calibration will be automatically loaded down. No one else in the diesel engine industry can do that thing. It is a true game changer, true differentiator. And it's all about data. It's all about creative use of data that they always had their hands on. So if there's one thing I would tell you right off, kind of the first blow your mind thing about the Internet of Things is don't concentrate on the device. It seems like everybody talks about the Internet of Things and everybody's worried about their Fitbits and all this other kind of stuff. I would concentrate first on the data. And then you may work your way out to the device, but it's more about the data. In my opinion, it's more about the data than the device. This is an illustration of what I was just talking about. So you can see that the various trucks and implements that have the diesel engines in them are able to send their data in. What that does is this then hits a queue inside a Cummins data center. It's actually in our cloud. And then because it has to queue up, it can't handle it all right away. What we do is we queue this data up. It then goes through what's called a streams process, where we cull out the good data from the bad data, that kind of thing. And then that then gets computed, recalibrated. In some cases, the feedback may go back to the application development people that wrote the firmware. In other words, they say, hey, we need to update the firmware. We need to have you make some changes to the firmware. Or it may go to the factory because we could actually make a change right, in the firmware that's being put into the embedded controllers right on the line. These 5 elements, the data and analytics on everything, the places where they build things, which is the factory, the messages from the things, how they design and test the things, and systems that feed and read things. These are the 5 components that we at Cloud One say make up the Internet of Things. So this is our conceptual model. And notice that data and analytics on everything is in the middle. It takes center stage. It's the glue, if you will, that holds everything together. What's interesting is the way we do it. Those 5 colorful things in the middle are other vendors' products. So it might be IBM Big Insights, it might be open source stuff like, Hadoop, MapReduce, Spark, you name it, right? HBase, etc. Or it may be other companies besides IBM, in the area of data visualization. It may be a company called Tableau or ClickView or something like that. So what we do is we take all of these kind of best-of-breed tools in these 5 categories and get them to talk to each other. We integrate them even though they may not have been designed from the start to be integrated with each other. And then what we do, our intellectual property is around the outside. So what we do that hasn't been done before, in other words, we put IBM tools in virtual private clouds, even though IBM hasn't figured out how to do it yet, that kind of thing. And then we offer license monitoring, what we call flexible licensing. We offer a lot of managed services and monitoring over it, and obviously the trust and security, because stop and think about what I've been talking about so far. What these companies are doing, this is literally their intellectual property. This is their keys to the kingdom, right? This is their trade secrets. So another big thing, when you hear about the Internet of Things and people start talking about, well, it's going to be, accessible on the public internet and this type of thing, not for companies like this, folks. All right? Companies like this that are putting their intellectual property on, they're never going to have their stuff on a public Internet of Things. This is all closed. We secure it. It's not accessible from the internet. That's the whole point. So here's another example. You're driving down the road, it's late at night, and you can see it's 2:51 in the morning, and you're kind of tired, and your computer notices that you're starting to shift lanes here, and so in your pop-up display, it says, hey, there's a Starbucks coffee 2 miles ahead. Would you like to pre-order your venti chai latte? And how did it know that? Because it already knew what? It already knew your favorite drink of choice was your venti chai latte. It knew from the automotive sensors that you were starting to waver across lanes. It already has your payment information, right? It already knew geographically from GPS that there was an all-night Starbucks 2 miles ahead, and so it went ahead and ordered this for you. You don't have to stop and pay or anything else. The venti chai latte is just sitting there. That system is being developed by Panasonic Automotive. Panasonic Automotive develops all their firmware for all their automotive infotainment systems on Cloud One. They have about 60% of the worldwide market, about 35%. The second place, having about 35% of the market, is a company called Harman Electronics, Harman Kardon, you may know them as. They're the second leader in automotive infotainment systems. They also develop their systems on Cloud One. So about 90 or 95% of the world's automotive infotainment systems are developed on our systems, this little old company in Indianapolis called Cloud One that's no one's ever heard of. Another example, there's a knock at your door, and there's this good-looking gentleman there, and he hands you a box, and in it is a set of washer hoses. And you say, but I didn't order these washer hoses, and you'd be absolutely right, because your washing machine ordered the washer hoses. All right? Why? Because there was a pressure valve on something called a 6 Sense Live Whirlpool system in your house that knew by the feedback on that pressure valve that one of your hoses was in danger of having a problem, leaking, etc. And so it ordered the proper hose, all right, had the hoses delivered. Oh, by the way, sent you an email that said what the availability of the local service guy was, etc., etc., etc. Whirlpool is developing their 6 Sense Live systems on Cloud One. One more example. So it's late at night, your flight was delayed, you just want to get to your hotel, all right? Wouldn't it be nice if you could just bypass the front desk and just use your phone with a system called Digital Key from Hilton, all right, and just wave your phone at the door and go right into your room without ever stopping at the front desk. That system called Digital Key from Hilton is being developed on Cloud One. That's the Internet of Things. So as I said, we're this little old company that you probably never heard of in Indianapolis, Indiana. When I first came, our revenue isn't all that impressive. Certainly there's companies with more revenue than us, even in the Internet of Things place. So when I first came to work for Cloud One, I thought, how do I capture what it is we're doing? How do I capture, instead of just stories like I just told you, how do I capture how significant this is, what our place is here? And so I added up all the revenue of the customers we had at that time, and certainly we've added some since then. But here's some of the logos. I know you'll recognize some of them. And at that time, it added up to over $1.2 trillion. So in other words, go back to what I said before about the intellectual property and the trust that they have in us. So that's why my title is Chief Trust and Security Officer, right? I'm responsible for over $1.2 trillion in trust. That's my job. So how's Cloud One different? And this was sort of the teaser that we put in the description of the talk tonight. This is the whole theme. And we actually have a book coming out next Thursday called How IoT is Made, and that's one of the themes of this. Will you be a victim of a victor or a victor when it comes to IoT? So unlike a lot of companies there's kind of two groups of IoT companies, really. There's what we call the widget group, and then there's the platform group. The widget group just has one thing, piece of software, a device or something, and say, buy my widget and integrate it, with your end-to-end system. The platform group says, we can make all your dreams come true in IoT, but here's the catch. You have to buy our system, throw out everything you have, all right, and start from scratch again. We don't take that approach. We say, go ahead and use what you've already invested in. If you're a company that's been making diesel engines since 1900 or whatever, you've got quite a bit of data. This is an interesting thing about diesel engines. I don't know, if it's environmental. I've learned so much about them, but they have to keep data for any engine that they know is still in production. All right? So if you know anything about diesel engines, they run forever. All right? And so they've got data showing that some of their engines from right after World War II, from like 1949, are still in active use today. So that's how much data we're talking about them having to collect. What we do is we relieve, so here's the other problem, and Michael and I were just talking about this earlier, is the companies needing to do the Internet of Things, they're not experts in IT. These guys make diesel engines, or they make medical devices, or they make garage door openers. They're not experts in this. And so this is what we do. We'll host it for them. We'll host and manage it for them. They can pay as they go. It's secure, as I said. Is that me? Yes. Is my coat ringing? Yes. Sorry. Actually, I'll sing what's that.
Order you some new hoses?
Yeah. It ordered me a water because I'm getting dry. And what we do is we take all this commercial software that they may or may not have purchased already, and we integrate it all together. Notice it all ends up, it's all about getting that data in the middle so you can do the analytics and visualization on it afterwards. And here's the point is, although we are an IBM partner, and I'll talk about that later. And let me just flip back for a second. Whoops, this way. So you see the colors, right? The categories of software, and then we bring them forward here. So in the different technology buckets, as I call them, there are a number of different, and these are just some of the companies that we've successfully integrated with in the past. Again, our competitive differentiators, this was the point of the talk, how are we different, all right? Rather than just supplying components, we build, we don't leave until the customer is satisfied that they have an end-to-end Internet of Things solution in place. We reuse their existing ones. We know how to deal with Fortune 100 customers, even though we're a very small company ourselves. And the bottom one is kind of important as well. If you look at some of the big consulting firms over here, like PwC and Deloitte, they make their money off of having a long-running project and have a lot of billable hours. And so, in other words, they're going to stretch that engagement out as long as they possibly can. Oh, thank you so much. Internet of Things. Whereas we take the opposite approach, all right? Because we don't really make money on the implementation. We make money on hosting and managing it for them after the fact, and then grow it over time, getting them more engaged, doing more and more. So our motivation is to make that implementation as short as possible, right? Get them implemented, get them up and running. I always say start small and build on our success. So here's some of the awards and recognitions we've gotten over the last year or so. We are an IBM partner. We got the IBM Beacon Award last year in the IBM partner ecosystem. There's over 100,000 partners, and we got the #1 partner award out of that. Inc. 5000, we were named to that. That's the fastest growing private companies in America. We've been named to that for the past 2 years. Fastest growing IT company in Indiana, past 2 years. And you can read some of the others up there. In the United States, our headquarters is in Indianapolis, but less than half of our employees actually work there. We have a small office in Dallas where our sales team is located. We have about 10 or 11 people up in Chicago in our Chicago Technical Center, and then people are spread out worldwide. Beyond that, we have offices in London, France, and Germany at this point. And I think we're about to open a big venture in China. So I've got one more slide that I think you'll find is fun, and then I'll just open it up to questions. So I couldn't resist putting this in. So what do Cloud One employees do in their spare time? So this is a true story. Our chief technology officer built something called an IoT fish tank. All right. Now, he doesn't have a lot of experience with product packaging, as you can see from the picture on the left. So if any of you are interested in being an intern and neatening this up, that might be of interest to you. So what this is, again, necessity is the mother of invention, or however that expression goes. So the guy's fish tank overflowed because something went wrong with his reverse osmosis filler system or something like that. And so he decided certainly there must be a way for IoT to control this, with feedback loops and so forth and so on. There's actually a whole slideshow about this out on SlideShare. I can send you the link or something. That's where I've got some of these shots from. But he built himself a dashboard, and I know it may be a little hard for you to see, but across the top, from left to right, it's temperature, pH, and flow. So he sees his metering there. Then he's got his kind of LEDs to show success of his different systems. So coming down the side, it's water pump, dosing pump Excel, dosing pump phosphate, CO2 solenoid, LED lights, water heater, filter pump, and then you've got the high-res camera in the middle. So it just goes to show, we love the Internet of Things. It's not just our job from 9 to 5. We kind of live it 24/7. That's what makes the job so fun. Is it's not for everybody, granted, but if you want to work in a field that literally is on the cutting edge, where you are literally defining the field yourself, there aren't too many of those opportunities that come along. That's what we're doing at Cloud One. That's it. Okay, so open for questions. Yes,
so
sir.
I'm not really an engine guy. Could you describe what benefits you would get from calibrating a diesel engine
Yes.
better and more correctly, I suppose?
Yes. So a couple of examples, okay? And thanks for bringing that up, because I forgot that. So Cummins is selling this system to the people that buy their engines, right? Like fleet operators, et cetera. Now, you have to understand the size of truck fleets. They may have 30,000 trucks or something like that. So one of their customers, one of their truck fleet owners signed up just for the beta program. And they put 2,000 of their trucks, 2,000 of their truck engines on the system. Now remember how I said the messages come in, right? And then they can do one of two things. They can look at that message that's coming in from that engine, and they can react immediately to it and send it off to an application, do some processing, etc. Or they can just store that data away in this big data warehouse, they call it a data lake, and do trend analysis and come up with the new calibrations out of it. All right? Here's the thing. What they did with some of the data that came in that was really more of the warning status is they turned right around and let that fleet operator know what warning just came up on such and such a truck, you know, and could send a message either to that operator or directly to the truck itself, to the driver, and tell them to pull over, or tell them to, you know, within the next 50 miles, here's a service center, pull in, make sure the part's there, et cetera, et cetera. Point of the story is this: on just 2,000 trucks, that fleet saved $100,000 a month in towing charges. All right, because why? Because what's the truck driver's motivation? He's just going to keep driving, right? Nothing's going to stop that guy. He doesn't care how many warning lights are on the dashboard. All right? until the truck literally breaks down and stops running. All right? Expensive repairs, et cetera, et cetera. All right? So where's the value? Where's the value to, you know, to the customer? The customers love this. You know, do they become more loyal to Cummins because Cummins is the only diesel engine company can do this? You bet they do. Because it's money in their pocket. It goes right to their bottom line. The point with the calibrations is there's two things, all right? So one's the emissions, you know, they want to be able to pass their emissions controls test. But the other is performance. So the more they can tune the calibrations, remember I gave you the example of it's sensitive to temperature or altitude or that kind of thing. If they can tune those calibrations, they can get better fuel economy, better performance, et cetera. So that's the other benefit. Yes, sir.
Where does most of your guys' revenue come from on your end? Continued service or initial, you know, setup?
It's much more on the continued service. Yeah, absolutely. And that's what we call MRR, monthly recurring revenue. Mm-hmm. And so when we set up a service, like even if it's for an existing customer, but you know, we bring in some new data and do something new with them, that's like a little mini system, and we establish what we call MRR for that. It's what we call mailbox money, because the checks just keep coming in. You open up the mailbox and there's the checks.
Do they buy the sensors from you, or do they have their own sensors and just give you the data and you manage the data?
It's both ways. It depends on the customer. In the case of Cummins, it was their embedded controller. It was their sensor, and so all we had to do was get the data off of it and, you know, store it in a data lake or a data warehouse, and then help them start to do the analytics on it and build applications that, you know, kind of dove in and did cool stuff with it.
Would you say that currently all of your processing occurs in the cloud, not locally between machines?
That's a good question. So it's a combination, all right, and it goes back to that sort of our philosophy is we don't make a customer tear anything out, all right? So let's say they got an existing system that runs in their own data center, what we call on-premises, all right? And we're just going to take, you know, data off of that system, or maybe even send data to that system out of our data warehouse. Our data warehouse is in the cloud. The big collection's going on in our cloud, but we still might talk to their.
I asked more along the lines of, so I'm a senior and I'm doing my thesis with swarm intelligence. So you have your Internet of Things and you have this local neighborhood of devices that can communicate between each other.
Mm-hmm.
Have you seen any sort of advances in that side of things where they machines interact within their own neighborhood, like fleet of trucks are all moving through the same sort of range? Or?
So that's sort of the mesh networking idea. And we don't have, I mean, I've certainly seen it and I'm aware of it. We don't have an implementation of that. We haven't had a need to yet. But I definitely think that is we were just talking about this earlier, I definitely think that's sort of where things will be headed, because the Internet of Things will just get too big for it to be a hierarchical network. It's going to have to be kind of an autonomous mesh network. Did that answer your question?
Yes.
Thank you. Hi.
So you made a very large point earlier about your systems being removed from the public internet.
Correct.
And I've been very interested in security for quite a while, and I was wondering what in that respect do you see as setting yourself apart from anyone else?
Okay, so what we did very early on, and unfortunately we didn't patent it, was this idea of virtual private networks and virtual private clouds. So we have a point-to-point pipe.
So I understand that.
Okay.
And I also I've through some of the mentors that I've had a chance to work with, I've seen some of the potential flaws in that, and you guys aren't the only ones implementing that either.
Correct.
And those types of systems have been compromised before. So I was wondering what in that paradigm, how do you guys see yourself as setting yourself apart from the rest?
I don't know, I mean, we haven't invented any new protocols, any new technologies.
Okay.
I think a lot of it is best practices, like you say.
And just staying on top of things.
Right, and doing a lot of, vulnerability testing and so forth, and that's where my experience with FBI comes in handy, because I know what the bad guys do.
I'm also interested in security, and I was wondering, what would you recommend for like a college student to learn or do to set themselves up for like potential success in security, cybersecurity in the future?
I guess the best advice I would have is, security is so broad now, is find something that you really love to do and get incredibly good at it. And so one of the things what brought me to the FBI was, early on I started what was called the Purdue Malware Lab. We started reverse engineering malware, which doesn't sound like any big deal today, but we were one of the first ones to do it. So you literally, this is sort of a good story. I mean, when I was back in school, I had to take a course in assembly. I don't know if they even teach that anymore. And I swore at the time that I would never, ever touch that stuff again, right? Well, then I said, you know what? I think if I could reverse engineer malware and look at a piece of software and figure out where they were, how they broke in, who they were, et cetera, that would really be cool. Well, guess what I did it in? I was using an assembly debugger. So, yeah, I was doing more assembly, a few years ago than I did when I was back in school. So never say never. So that's what, I mean, I don't know if that really answers your question, but I would find some niche that is really fascinating for you. I will tell you, beyond the shadow of a doubt, that the biggest barrier to entry, the biggest concern, whatever you want to call it, about Internet of Things, from a CIO perspective, is security. So IoT security. Now the trick is, even if it's not really IoT security, if you call it IoT security, you might make yourself a lot of money. So in other words, the point is, I think it's really more about device security, embedded software security, firmware security, that kind of thing. It's usually it's the bad guys break in from the edges, and so if really all the Internet of Things is you've got autonomous devices acting independently without human interaction. That's what the Internet of Things is, right? You got a device out there that's fully functional. It can contribute data, it can extract data, it can analyze the data, and it can take action based on the data. That's what the Internet of Things is. So if you want to concentrate on how do we secure that thing on the Internet of Things, right? To keep bad guys from building botnets out of them or whatever, that would be a good thing.
I have to say, when you started talking about fleets of diesel trucks, all with embedded computers, I was really hoping that you were going to a diesel botnet.
Oh, yeah. A diesel botnet, diesel-powered botnet, yeah, pretty cool. Well, you heard how they took over the, what was it, a Jeep Cherokee?
Yeah.
Yes.
So does Cloud One develop their own security methods, or they're like actually using others?
It's a combination. So as I said before, it's not like we're developing our own security technology, but definitely our own methods, yes.
Okay. And then how do you like promise the customers that you're secure?
So that's a very good point, and it makes me want to talk about this title of trust, because you've probably heard of chief security officers, but you may not have heard of chief trust officers, and it's more than just semantics. Okay, so what trust is really about is, it's not so much about contracts and SLAs. In other words, as a customer, what would you assume I'm taking care of on your behalf? That's the trust relationship. You trust me that I'm doing what, all right? And so that's why we call it a chief trust officer, because it's not about, you know, the fine print in the contract we signed that said, you know, you indemnify me for that and I'm not liable for this, all right? It's what do you trust that I'm taking care of for you? So that's one difference in our approach from a philosophical standpoint. All the way to the back.
I'm a mechanical engineer, so I like getting my hands dirty. So what would you suggest to someone who's wants to build their product or their process with Internet of Things in mind, like starting from the ground up with it?
Okay, so you're the thing guy for the Internet of Things, all right? And so what you need to do is find a buddy, all right, that likes developing software. Because if you're not a firmware guy and you know, you didn't have to take assembly, so you didn't. You need to find somebody that took that assembly class and actually thinks it's kind of cool, all right? So that's on the thing side, you know, that's the big deal. I would say on the software side, beyond just the firmware place, the real opportunity we have, or the shortage of talent we have right now, is in the ability to write applications that can go down into the data warehouse, into the Hadoop environment, and actually write an application on top of that. So you may or may not know much about a Hadoop architecture, but there's a processing layer called MapReduce above Hadoop, and basically you write in Java in order to kind of work your way down through MapReduce, which literally maps the data, tells you where the data is. You kind of churn it and come back out with your results. Those are called Hadoop developers, not to be confused with Hadoop database kind of configuration, maintenance type of people. So Hadoop developers or Java developers that can teach themselves MapReduce and that kind of stuff, they're like solid gold right now.
I was working with Cummins this summer, and they're like they're working with Informatica as another company that's dealing with big data and stuff. So how do you like separate, like let's say Cloud One is more advantageous than other like same type of companies?
So the difference is, for instance, in that color wheel that we had, Informatica might plug in one of those colors. So we're not selling a product, we're selling a end-to-end solution. That's probably the best way I would describe it. We're solving a business problem for our customers. You know, whereas other IoT vendors are saying, please buy my whatever it is. Once you bought it, it's like, thank you very much, see you later. Good luck integrating it, you know, that kind of thing.
Since you're saying IoT growing, you know, from your standpoint, is it growing more based on, all right, we're going to retrofit old machines with new sensors and get data from them, or is it more of new machines with these sensors and the firmware into them?
It's all of the above, really. And it's also just reanalyzing data that's been gathered from machines over a long period of time and finally having the processing power and the ability to look across all that data, you know, in new and inventive ways. Another thing that's happened is, you probably, you know, are familiar with this, in large corporations, you end up with what are called silos, right? Business divisions. Those business divisions each have their own budgets. They can each buy their own software, right? And have their own IT environments. Well, what happens? Their data from their systems get locked up. You know, this business division over here has their own IT systems, their data, that's locked up over here. But, you know, think about the end-to-end process across the whole company, right? You don't get that full view unless somehow we pull everybody's data up where? Into a data warehouse, into a Hadoop environment. Now, we can do trend analysis across multiple sources of data that up until now, they were just locked up. They couldn't see the correlation between what happened in the factory and what happened out in the field, that kind of thing. Because it was two separate divisions of the company. Yes, sir.
So what makes it practical for you to develop something around existing software? Existing software is traditionally very hard to deal with. Can you tell us a little bit about the kind of techniques you use or anything along that line?
Yeah, so fortunately, a lot of software you know, has something called an API, an application program interface, and so that's what we end up dealing a lot with. So obviously we're not going to get the source code, you know, from these other vendors' products, but they almost all have APIs, and so just to understand that API is not the same thing as a connector, right? So a connector is a fully developed piece of software that says I can transparently make this talk to this. An API just says, here's a manual, dude, knock yourself out, all right? And so what we do is we work with the APIs and we actually build the connectors between, I would say, between two pieces of software that don't want to talk to each other. So that's sort of, you know, our niche, what we get our kicks out of.
Do you have a rough estimate of how much data you actually have that you're storing for your clients?
It's in the petabytes, yeah, and it grows daily. It grows daily, yeah. And the other thing, remember what I said is many of these companies, because of warranty and liability, so forth, they can't ever destroy the data. And so, you know, once you get the, you know, the engine started, the data eating engine started, it's not going to stop.
Well, before we, our time is just about up. I wrote down my email address, my username, which is just my last name, WOLLOWSKI. If you would like to learn more about this stuff, you mentioned that there's a video that people might be interested in seeing. Also, John, his boss, former student, wrote a book about the Internet of Things, which is very insightful. So it gives you a view of the Internet of Things that is hidden from public view. The public Internet of Things is peanuts compared to what's going on in the business world. And so that book is going to come out next Thursday. I can send you a link to it. It's going to be available through Amazon.
It'll be available on Amazon.
And I will see that we're going to get a copy to put in the library. And so if you want to learn more about this stuff, send me an email. I'll send you that information. Make sense? Well, let's thank Jim again. And thank you all for coming.
Yeah, thanks.